All right. How am I going to integrate this? U substitution. What do I choose as the inner function? Right? If I let U equal tangent of 5x. So one of the things that you should look for when you're doing a U substitution, you should look for the derivative of one of your functions in the problem. And as soon as I saw a tangent and a secant squared, that should be my clue that tangent is my function because the derivative of tangent is secant squared. So du is going to be secant squared 5x times the derivative of the inner function, which is 5, correct? So I need, dx. My du is basically 5 secant squared 5x dx. Who of you in here are looking for the du in the original integral? Is that the majority of you? So how did I handle it that way with this one? Because I have 25 secant squared 5x, not 5 secant squared 5x. Yeah. Do I put 1/5 on the outside? So I need 5 on the inside, right? I need that to be a 5. So I put 1/5 on the inside and then 5 on the outside, correct? If you were trying to do this by solving for dx, I would end up with the integral of 25 secant squared 5x over u, and du or dx is du over 5 secant squared 5x, and then my secant squared 5x reduces and my 5 reduces. So either way, the 1/5 of the 25 is going to get me 5. This one here, doing it that way, gets me the 5 secant squared 5x dx. Or if you were struggling, because usually we put the multiplier that's a non-fraction out front and the fraction out or inside and then the fraction outside, you can always solve for dx, substitute in and reduce. And either way, what we end up with is 5 times the integral of 1 over u du, or I could write this as du over u. Both of those say the same thing, right? If you're given a problem like this and it drives you crazy because you have a hard time seeing that it's the du at the end, then rewrite it as 1 over. Okay, but now what is the integral of 1 over u du? Absolute value? What? Oh, the natural log of the absolute value of u. Oh, thank you. Plus c. How many of you are just starting now to substitute in the u right away? Is that what we get? Did we get that? Do we agree with that? How many of you struggled on this one because you didn't know what the u needed to be for the u substitution? Okay. So what I said, did that help? Look for the derivative. That'll help you see what you need to start with for the u. Right. What if like we did u as like secant squared? It won't work because the derivative of secant squared is not 1 over tangent. Right? So if you tried that, you're going to still have x's and u's in your integral that you can't undo, that you can't get rid of. So sometimes you'll choose the wrong U and you get stuck where it won't work. So then you've got to go, okay, let me go back and choose a different U. All right. Now, the last thing I need to look at, will tangent of 5x always be positive? Or, well, yeah, will tangent of 5x always be positive? No. So I need to leave the absolute value symbols. Does that make sense? Okay, let's look at the second one. Are there any questions before? Yeah. Because what we did last time, the derivative of natural log of absolute value of x is 1 over x, which means the integral has to be this one. So we always have to have absolute value there. Because otherwise, if you're thinking about it, I can't take the natural log of a negative. So I have to include that, because if the x that I want to plug into the natural log would have made it negative, I have to have the absolute value there. Okay. Let's look at this one. So using that same philosophy, do I see a function and what looks like possibly, probably some manipulation of the derivative? So in that case, what will my u be here? X squared plus 2. So du is 2x dx. And again, I'm going to see that other. What do I need here if I'm going to look for du in there? I need 1/3. Is that all I need? I need the 3 on the outside. Is that all that I need? I also need to undo this negative, right? So I need those also to be negative, correct? So when I do that, I'm going to get -3. Oops, I was going to change colors. Oh, well, -3, 1 over u du. And again, if I solved for dx, that -3 would out when I reduce. Okay. So now I get -3 times the natural log of the absolute value of u plus c. This is what I'm saying. How many of you are going from here, and instead of taking the 2 steps where you do the integration in terms of u and then substitute the u in, how many of you are just doing the integration and substituting the u at the same time? Does that work? Can I do that? Do you need to see the intermediate step where I had equals -3 times the natural log of the absolute value of u? Now I need to look at this again. Does x squared plus 2, is it always positive? X squared is always going to be positive because we're dealing with real numbers, not imaginary. Yes, I realize when I square imaginary numbers, I get negatives, but we're not doing that. We're squaring real numbers. Real numbers squared give me positive or 0. And then I add 2 to that. That will always be positive. So the expectation then is that statement is there defending why you removed the absolute value symbols. For me, you do. For the AP exam, I do not believe that they require it, but I'm requiring it on mine because I want you to think about the necessity for absolute value or not. The necessity is there because I cannot take the natural log of a negative number. If that number inside the natural log can never be negative, I don't need the absolute value symbols. And you have to defend why. And that doesn't take a big defense. I do not want you going straight to here. I want you doing the antiderivative with the absolute value symbols and then thinking, is there a need for those absolute value symbols? Yes or no? And this is an acceptable defense. You just told me that what's inside the natural log is always positive. We're good. Okay? Any questions? Any questions on the video that 4 of you watched?
The YouTube videos.
I fixed it. Yeah. I don't know how that happened. Well, I do know how it happened. It was I had a brain fart, and I have those regularly. But I don't know what my brain was thinking mid fart. So yeah, I'm not sure why it's not even calculus. It was pre-calculus. So anyway, yeah, so I have fixed it. That YouTube video, the Screencastify video, I never made a YouTube video. So I don't know what I did. But it is now, the YouTube link is correct. I believe. I tried to click on it and YouTube was still processing the video. So I don't know how long that takes. Yeah. Shh, you're being rude. Thank you. What?
In the notes for problem number 6, in which integral tangent x dx, and you said that we got 2 answers that we should have written. One of them, the negative.
Oh, right. Yeah. Because, okay, let me go there so that we can reference that.
I was just wondering which one, like, are both those okay on the test?
Yes. So if I were, where was that one? There. Either one of these are okay. They're going to be the same, whichever you prefer to have memorized. I'm trying to remember if the integral of tangent of x is a required memorized one for the AP exam. So I will need to look at that. But either one of these are correct. Most of the time, I think kids prefer this one because they don't like that. But they're the same integral. It's totally fine. You would not have to give me both. I'm assuming is your next question. Do I need to give both? No. This one or this one is fine. But I didn't want you later in a different calculus class to go, that's not what Mrs. Burleson showed us the integral was. There have been things in our textbook that when I give the antiderivative, that if you use like sometimes photomath, or there are some calculators that will do the symbolic integration, not just the definite integration. And they sometimes give different answers. And I wanted you to understand why they look different, but are still the same. So that's a really long answer to your question. Yes, either one of them are fine. You do not have to do both. Any other questions from the video? Any questions from the previous assignment? The derivatives, right? Natural log differentiation. Which?
Okay, I have 2 questions.
Yeah.
So, 60, and then 91.
Starting 5. No, it starts in 7. So which one?
60 and 91.
60 and 91.
30. Did you also do 72?
60, 73, and 91. And this is from section 5.1, right? Any others from the previous assignment? Pardon me? Any others? Okay, 60 was f of x equals the natural log of x plus root 4 plus x squared, right? So f prime of x is going to be 1 over x plus root 4 plus x squared times times the derivative of the inner function. So the derivative of x is 1 plus the derivative of the square root of 4 plus x squared is 1/2 of 4 plus x squared to the negative 1/2 times 2x, right? Derivative of x, well, let me do it this way. Derivative of x, and then the derivative of the square root. Does that help?
Yeah. So you're taking the derivative of the natural log function.
Puts it in the denominator. And then this ends up being the 2's reduce. I end up with x over the square root of 4 plus x squared, which I think is the way I might have written the answer on the answer page.
So you always just have f of x and then or
You have that simplified further on the answer page. Yeah.
I have it simplified further.
Yeah. Well,
So I just copied the answer out of what they gave in the
because
book.
what you can do is you can multiply the
Oh,
ones
they did.
by
Oh, yeah, they did. Yeah.
that.
Right. Yeah. So here's what you can do. Let me show you how to do this on your calculator if the answer that's the final answer looks different than what you have. So I had 1 over x plus the square root x plus the square root of 4 plus x squared times I had parentheses 1 plus x over square root of 4 plus x squared. That was the answer I gave, right? That's the one I simplified it to. And then I believe the answer that I had was 1 over the square root of 4 plus x squared. Is that what the answer on the sheet looks like? So now if I graph, let's pick a better window. I don't need my y's to be as big. Let's go -1 to 1. And now graph it again. Do I have the same derivatives? It is possible that when you did this, let me just show. Oh, no, let's go plus 0.1. I think that'll do it. It is possible that you'll see something like that when you graph the two derivatives. Is that okay? Does that mean it's the same derivative? Yes, because of the plus c, right? we can't graph the plus c because we don't know what that constant is to make sure that they lay down the same. Do you see that the shape of that antiderivative is the same? The difference is a vertical shift. That's just the difference in the plus c. Okay. So if your answer doesn't match what I have on the paper, you can do this really quickly on your calculator. Do the graphs look the same? There may be a vertical shift, but that's it. And if their shape is the same, you have the right antiderivative. That's how I grade your tests. If you do something different and get something that looks way different than what I have and it's super complicated, and I don't want to take the time to try to simplify it down to the answer I got, I just plug them in. Yep, they have the right derivative. It's not worth trying to do the extra simplifying. Does that help? Is that the issue for the other ones? That it didn't match the answer on the paper. All right, so 63 was y equals the natural log of the absolute value of cosine x over cosine x minus 1. Remember, the derivative of the natural log of an absolute value loses the absolute value, right? So that shouldn't bother me that I have those, but I am going to use properties of natural logs to make this an easier, natural log of, right? If I have division inside, I can have subtraction of the exponents. So now when I find the derivative, so the derivative of natural log of cosine of x is 1 over cosine of x times the derivative of cosine of x. And then I have minus derivative of natural log of something, puts the something in the denominator. And then the numerator is the derivative of what was inside. So if I simplify this, I get negative tangent of x plus the sine of x over cosine x minus 1. Next question was 73. 73 is implicit differentiation. So I have x squared minus 3 times the natural log of y plus y squared equals 10. So if I do implicit differentiation, anytime I take the derivative of an x, I'm good. Anytime I take the derivative of a y, I have the chain rule, and that gets me a dy dx or a y prime. So I don't know if the directions asked for find dy dx, but if that's what they tell you to use that notation. So the derivative of x squared is 2x minus 3 times the derivative of the natural log of y is 1 over y times the derivative of y with respect to x. And then I'm going to do the derivative of y squared is 2y times dy dx, and the derivative of 10 is 0. So then here I'm going to factor out the dy dx, and I'm left with negative, let's go 2y minus 3 over y. And then the 2x needs to move to the other side. So I'm going to divide both sides by 2y minus 3 over y. So I get dy dx equals negative 2x over 2y minus 3 over y. And is it okay for me to leave the y in the denominator? in the denominator. The y in the denominator. So the way I undo that is multiply by the numerator and the denominator by y, because I've got the form of 1. So that gets me dy dx equals negative 2xy over 2y squared minus 3. If you solved the other direction, then all of your signs change. It's the same thing. And what was the last one? 91. Any questions on that one? And then 91, you're supposed to use logarithmic differentiation. So I know that y equals x squared times the square root of 3x minus 2 over x plus 1 quantity squared. So using logarithmic differentiation, I'm going to take the natural log of the left and the natural log of the right. And then I'm going to use logarithmic properties. Is there anyone in here that just goes ahead and does all of them at once? Are you able to do all of the natural log properties at once? Like recognizing the numerator is going to be addition with exponents and the denominator is going to be subtracted with an exponent. So I'm going to have 2 ln x plus 1/2 ln of 3x minus 2 minus 2 ln of x plus 1. Right? Do I need to show the intermediate steps? I will if I need to. Did I lose you, Kara? You're seeing over the heads. Okay. Sorry. Here. There we go. Okay. So now I'm going to take the derivative. I'm going to do implicit differentiation, the derivative on each side. So I've got y prime over y here. And here I have 2 over x. Derivative of ln of x is 1 over x. And I multiply that by 2. I get the 2 in the numerator. And then this is 1 over 2 times 3x minus 2 times the derivative of the inner function is 3. Derivative of 3x minus 2 is 3. And then I have minus 2 over x plus 1. I probably gave you the combined answer. Please don't do that. Stop here. Well, I'm actually not quite done, but don't worry about combining these. So now I don't want to know what y prime divided by y is. I want to know what y prime is. So that means I need whatever y is times this. And y was x squared times the square root of 3x minus 2 over x plus 1 quantity squared. Did I get that right? Oh, y prime. Thank you. Yep. I said y prime, but then I said multiply by y, and so my brain stopped. Any other questions? So we have just under 50 minutes in class for the integration assignment, correct? Exponential. I know for a fact that that video is less than 40 minutes because I had less than 40 minutes to do it and I had time left over. I think it's less than a half an hour. Yeah, it's pretty short. And we cover integration and derivatives and integration of exponentials. So it's a not a difficult